Okay, let me give you guys some more examples of proportionality. So here, let's say you've got a pendulum here. The length of the pendulum is given by L, and T here is the period of one swing. Okay, and G here is gravity. So the formula for pendulum is given by this. But by the way, at the moment it's this bubble here times this bubble here. That's how you should read it. Now, suppose you want to know what would happen to the period if we were to vary L. So if we were to change the length of the string, how would that affect the time for one period? Okay, so what you do, you start with your formula here. At the moment, you've got this bubble multiplying this bubble here. Okay, so start with this here. So everything will be the same. So gravity we will keep constant. It's just so gravity here we will keep constant. It's just the L that we're varying. And suppose we're changing L all the time. How would that affect T? So we're keeping gravity the same but changing L each time. So start by doing this. Hang on. You need to remember indices. Remember from indices. If you have something like this, A over B, and if you don't understand this bit here, then you've got to watch the earlier section on the indices. You see this here equals this, and I showed you this already in that section. So if you don't understand this, then watch the previous watch the indices section. So here you visualize it like this. You've got 2 pi. That exists in a bubble here. Okay, this exists in a bubble here, and then you're multiplying with this thing here. But I'm going to break it up to so it's like this: L and then over root G. Now I'm allowed to do this by using this thing here, A over B. And if you don't understand this, watch the indices section. So I'm just using this property here. So so here I've got another bubble here. So it's basically this thing multiplying to the top. Okay, so this can be written as this. Hang on, can be written as this: 2 pi root L, and then all over root G. Okay, so now hang on, let me move this down. So now we remember we are varying L. So all that we're interested in is the L. This G here is constant. It doesn't change. We're keeping the gravity the same. So now visualize it like, well, take this bubble out here. So at the moment you've got this bubble timesing this bubble here. Take this bubble out. So it will look like this. 2 pi over root G times root L. Okay, so it's just like me saying, oh, I've got a bubble here multiplying a fraction. So when you multiply a fraction, it gets multiplied to the top. Basically, I am allowed to move this bubble out, so it becomes this. Now, if you look at this here, remember we are just varying L. So L changes, but gravity is always the same. Basically, this number 2 is always the same. Pi is just a number, 3.1, blah blah blah. It doesn't change. So this whole thing here, it would be a number that doesn't change, and it's a number that we don't care about. So I'm just going to give it a new name, K, a new constant, K. So that whole bubble here, I'm just going to call it K. Okay, and then so we've got K times root L. Okay, so basically, so this is T here, and then you've got K. You can write it as this, K L. Okay, so when you write this next to a square root, it basically means times. So here you've got K times root L. Hang on, K, yeah. So once you're here, you can actually say T is T is proportional to the square root of L. Okay, so what that means is, well, remember that if you're told that T is proportional, let's just say T is proportional to let's say just L. Okay, you can visualize this equals a constant times L. Okay, so now this bit here, we are here, so that's this bit here, and we are working backwards to jump to here. So basically, we were here, and then we can make this statement here. So t is proportional to the square root of L. So what that means is, hang on. So let me clear all this. So we can actually make the statement t is proportional to the square root of L. So the minute we're given this here, we can visualize this. T equals a constant times root L. So what that means is, suppose you were to double the length here. So currently, let's say this is our current situation. This is our current situation. Okay. So our current situation, when the length is L, this will be the period. This here will be the period. So this is current. Okay. Now suppose we have a new situation. Suppose we have a new situation where the length of the string is 2L. Now let's put this into this L here, but it will be a new situation. So hang on. So our new situation, T. So this is our T new. Okay. This is our T. Let's change it to old now. This is our T old. Now we've got to investigate TL. Sorry, T new, but the length is 2L. Okay, so it'll be K root 2L, because we are investigating a new situation where the length of the string is 2L, twice the length of this. So basically it was just L. Now the length is actually 2L. Okay, so how will the new time compare to the old time? So when you are here, you've got to try and express the new time in terms of the old time. Now this sounds a bit weird, but it does make sense if you watch it for a bit. Hang on. So now so you've got this thing in here, square root of 2L. Okay, you need to use another property of indices. So when you have this here, this equals square root of A times the square root of B. You can actually break it up like this. Now if you don't understand this, watch the indices section. Okay, so now I'm gonna visualize a new time, T new here, as this: K times the square root of 2 times the square root of L. Okay, so basically at the moment you've got this number here times this thing here times this thing here. Okay, this is our time for our new situation. Okay, now we've got to somehow express the new time in terms of the old time. So we want to express it so it's like this. So we can so that we can compare it with the old time. Okay, so now if I concentrate on this bit here and somehow express this thing in terms of the old one here. So now I'm going to rearrange it. So hang on. So I'm going to rewrite this as root 2 times K and then times root L. This is an ugly way of writing it, but I am allowed to do it. So this is the time of the new one. Now look at this here. If you look at this is our old time. Okay, our old time is given by K root L. Now look at this, K root L. This is our old time here. Now our new time is going to be this, whatever this is, times our old time. Remember, what's in here is our old time. You see, when we were here, we want to rewrite it in a new way where it involves the old time. This is the old time here. So now we can compare the new. We can compare this new t in terms of the old time here. Well, the new time will be. Hang on. Let me square root 2. What is that? Hang on. You see what I mean later on. 2 square root of this. I'm going to round it off to 1.4. Okay, so hang on. So this equals 1.4 1.4 the old time. Okay, so here, hang on. So by doubling the length of the string, you're actually going to increase. Well, it's going to be 1.4 times the old time. Okay, but by looking at this here, so by doubling the length of a string, you're going to times the time by the old time by 1.4. Okay, and you can use the same technique if you want to times the length of the string by 7. You can use the same technique, and what you do is you look at this number here in front. That will tell you how it relates to the old time. Okay.